Go ahead. Question 27. Leanne measures her height to be 168 centimeters. State the uncertainty of the measurement. Do not round the final answer. What do we need to get to our uncertainty first and foremost? We need our precision before we find the uncertainty, right? So let's do that. Precision is based on this. We know it's 1 centimeter, yes. Our uncertainty is just going to be that divided by 2. So it's plus or minus 1 divided by 2 is 0.5 of a centimeter. So here we go. You can go plus or minus 0.5 centimeters. The province does not require you to have the plus or minus when you're just stating the uncertainty. But there we go. One mark. Let's keep going. Explain why pharmacists must use accurate dosages when preparing medications. You can just say if the dosage is too low, it could affect the effectiveness of the medication, of the meds, right? That's one. If dosage is too high, it could cause an overdose. And it could also create a lot of side effects. They actually say you could also say if you use too much, you could lose money. That could also be an appropriate answer. So remember, can I just say, here it said explain. So elaborate a little bit more than if it's just state. If it says explain or describe, a bit more. Good? Keep going. Remember, this is your favorite unit, right? Given the following measurement, state the minimum value. Do not round your answer. So if it says minimum, all we have to do is 56 minus 0.3, and that would give us 55.7 millimeters. Make sure you use units, and that's the minimum there. State the tolerance of the measurement. How would you do this one? I hope that on your study sheet you have tolerance. The main way to figure out tolerance is you go max minus min, like the greatest allowed measurement minus the smallest. Okay. I will just quickly figure out my max. My max is 56 plus 0.3. So that'll be 56.3 millimeters, correct? Okay, so this is an aside. I'm going to underline it because it's important. So then you just go max minus the min, and that's 0.6. That's your tolerance in this scenario. So in essence, the tolerance is always you taking the maximum and the minimum away. Tolerance indicates the range of acceptable values so that the part or the item can still be used for its intended purpose. Okay. Let's keep going. Three of the four forms of tolerance listed below indicate the same measurement in megahertz. Choose the form of tolerance that indicates a different measurement. Okay. All right, let's try this. Whenever you have a tolerance, you can always find the min and the max. Okay? So let's figure this out. The max here is 16.3. The min is 15.7. Okay? This is already, so this is telling us that A is the same as B, right? They're the same. So I'm going to go check, check. They're the same. Let's try C here. 15.7 plus 0.3, the max would be 16. Uh-oh, that's already that's going to fail, right? The min would be 15.4. That one fails. I'm just going to keep going one more time to check. This one, the min would be 15.7 because I don't subtract anything, and then the max would be 16.3. So these three are all the same. C is the one that's different. And I'm going to take the time here to just review something real quick. 4 ways to state tolerance. There are 4 ways we learned to state tolerance. The one of them is nominal plus or minus half of the tolerance. The other one would be max plus 0 minus tolerance. The third one would be min, in no particular order, by the way, minus 0 plus the tolerance. And then there's the one where it's just max over min. Let me just add something to this one here. You see the first three ways have a number leading it. You see that? That is always it's always the nominal as well. Okay? Target. Nominal is the target, right? So I will highlight that in this way. And you're like, what about the last one, Mr. Dirksen? There's no nominal there. The province tells us that in these cases, they will not really ask us for the nominal, okay? If it's just min and max stacked, they're not going to ask for it. So you just need to know in these 3 scenarios, there's nominal. There's one variation though. There's a variation here. So let's say there's like 14.7 kilometers minus 0.4 kilometers plus 0.2 kilometers. See that this one right here doesn't fit any of these categories. Like there is no 0 here. Both numbers are actually non-zero. Can you still get your min and max out of this one, guys? You can, right? So subtract to get your min, add to get your max, subtract the max and the min to get your tolerance. I can see that the tolerance is 0.6, by the way. I don't know if you can, right? You go from negative, right, 4 and 2, that's a 6 difference. But to be safe, just go max. So I will say max is 14.7 plus 0.2. That's 14.9. The min is 14.7 minus 0.4, which is 14.3. Tolerance, you go 14.9 minus 14.3. That's 0.6 kilometers. Oops, that's off the charts there. So max, min, tolerance. What's the nominal in this case? Big number up front, 14.7. 14.7 kilometers is our nominal. I'm going to highlight that and highlight that here. Okay, so just a little review for you to go off of. Where are we at? Keep going. Give you some time to copy that. This is on page 30 if you're wondering, if you want to write this down. Just going to pause this here. Question 31. The recommended oil capacity of an engine has a maximum volume of 52.5 and a minimum volume of 47.5. That should tell you, okay, this is like a tolerance question. State the measurement in the form nominal value plus or minus half the tolerance. And this is an older exam, guys, because we all complained, we teachers complained, and rightly so, about like what's the nominal. So in the 2019 and onward, they said we will no longer make students guess what this is. They'll have to state it clearly, okay? So in this particular year, the nominal was this, guys. Max plus min, like we're gonna add them up and divide it in half. Right? That was the way to do it. So we go 52.5 plus 47.5 divided by 2. That's 100. Divided by 2 is 50. So that is my nominal milliliters. And what's the tolerance? Because we need the tolerance, right? We just go 52 max minus min. What is that? Is that 5? I think it's 5 mLs. And now I'm ready. Make sure you always answer the question. Okay, now I'm ready to state. So the measurement would be 50 milliliters. That's what we're targeting, plus or minus half of what the tolerance is. This answers the question. And remember this, if anything else you forget, remember there's always a max, a min, and the difference between them is your tolerance. And the nominal is somewhere in here. Okay? The nominal is somewhere in between here, is what it's our target. It could be the min, guys. It could be the lowest, it could be the highest, it could be anywhere in between, like whatever the industry wants, like that's the target. Okay? Let's keep going. Oh, sorry. Sure. Is that good? Okay. And we're entering stats, and then we're almost done. You good? Okay. Page 32. Explain why the tolerance of an oven's temperature needs to be considered when baking a cake for 30 minutes. What would you say here? Anybody in cooking class? I'm just gonna use my imagination here, or like what I know about baking. If you set it to 300 Fahrenheit or 350 Fahrenheit, there's a chance that it's actually 360, right? Or 370, like we don't know exactly. But if that's the case, if the recipe says put it in the oven at 350 for 30 minutes, it could be that I burn it because I don't know exactly that it's 350. So within this context, I would probably say something like this. Well, if the temperature is a lot higher, it will take less time to bake it. So I have to consider that, or else I may burn it. Or you can say, if the temperature is lower than what it says, it might actually take longer than 30 minutes. And you could, hey, let's throw in some safety in there. If you're cooking chicken and it's undercooked, food poisoning, right? I don't know, like just as I'm saying, this is the key word for me. Explain is like explain a situation. Tell me why you're saying this, right? Oh, okay, now we see that you understand. See? So if the temperature is higher than the setting, it will take less time to bake the cake. Sorry, the chicken is out of the question because it says we're baking a cake. Okay, so I read it again. Okay. So I'm just making the point that it's going to take less time to bake it. You can also make the point that if you keep it at 30 and it's higher than what the setting is, that you may burn it. So I'll leave that up to you. I'm just going to keep going here. Yeah. Okay, keep going. Ooh, this is a good one. What's the precision of this dial? Oh, I remember Mr. Dirksen saying, look, 400 to 500, see? It's 100. No, it's not from number to number, it's from marking to marking. So you either guess, you're like, let's see, 1, 2, 3, 4. So it's 4 spaces from 200 to 300. So 25, right? Wouldn't you say 25 degrees per marking? But if you don't know, sorry, not tolerance. Precision, in this case, my goodness, this thing has, all of them are broken. Like every, see, I'm out. Let's try it again. Here, try it. So I'll tell you this. I would have this on my study sheet. I would say max minus min. No, I think I said high minus low, right? Let's stay consistent here. High minus low divided by gaps or spaces or whatever. This is to get the precision. So you pick any two numbers. Let's say I pick 200 and 300. So I'm going to go 300 minus 200. Make sure you do that first, then you divide. I'm going to count 1, 2, 3, 4 gaps in between those numbers you picked. So that's 100 divided by 4, which is 25, what is it in this case? Degrees Fahrenheit. That does give us units. Morning. Degrees Fahrenheit. Yes. Let me see. Precision, no. Uncertainty, yes. Did it ask for No, it asks for precision. So we're good. The uncertainty would be 12.5, right? Plus or minus 12.5. Statistics. Statistically speaking,